In this video, we're going to look at how we can apply stiffeners to beam elements that have been converted to meshable panels. In this example, I have a wide flange section that's been converted to meshable panels with their respective thicknesses for the flanges, the webs, and so on. And my goal is to provide some stiffeners to enhance the shear strength within the section itself. So what I'm going to do first is I'm actually going to define a new coordinate system. And this coordinate system is basically just going to be a rotated version of the one that I already have. So here I can essentially place my coordinate system to a new point by just left clicking with the coordinate system tool. I'll left click here to activate the tool, and then left click here to place my coordinate system. And what I want to do is I want to make sure that the XY plane of my coordinate system, my user coordinate system in this case, is in plane with the flange of my beam. So I'm just going to right click on the user coordinate system tool to access some additional controls, such as being able to rotate this about the x-axis. Again, the x-axis here will, if I rotate 90 degrees, this will make sure that the y-axis is pointing in the vertical direction and the xy plane will be in plane with my web. So I'll click OK. And here we can see that that has taken effect. I'll maybe just save this as well. So I have a few different UCSs I was practicing with, but I'll call this member test. And what I want to do is also activate a grid. Now for this application, the grid that we use is not really that relevant, but we do need to have a grid activated for this to work. And this allows me to take advantage of the panel's patterns tool. So if I click on the panel element tool, you notice here that we have this patterns dropdown. It's currently populated with data that I was working with, but I'm just going to set it back to none. This is what we would normally see when we're working with panels. But now when I have this grid activated, here I can choose from a number of different panel patterns. We have a video actually on the wall panel patterns, for example, that you can find here. I'm going to use the stiffeners option though. So when I click on the stiffeners option, we have the option to not only specify the panel thickness, which we could with any other type of panel. We can choose the type of panel that we're using, the width, so it's basically the dimensions of our panel. Which these are going to be stiffeners, so this is basically going to occupy the space between our flanges and our web. So 0.15 meters is my width, and 0.325 meters is my depth, and that would be found using the measuring tool, the dimensions tool rather, in the CAD details window. I can also specify my mesh parameters, and at the bottom here I have this spacing command that allows me to specify spacing for this particular application. And this will all be with respect to the coordinate system. My user coordinate system's going to act as my datum. So everything is going to be along the x-axis. So I can say I want to have one stiffener at 0 meter spacing from this origin of my coordinate system in the x-axis. And then maybe I want to add another couple here. So I'll say I'm going to have 2 at 0.5 meter spacing beyond that. And then maybe another, I'll say 3 at, sorry, I can't type, 1 meter spacing. And once we've entered all this data, we can then click OK to accept the changes, and then simply click on the point that we want to place this at. So I'll just left click here, or sorry, left click on my panel. And you can see that it's placed those stiffeners at the spacing that we've indicated. So we have one at the original location at 1 at 0 meter spacing, then another 2 at 0.5 meter spacing from there, and then we're moving out to 3 at 1 meter spacing. And if I wanted to continue on, I could add more, or I could even move my my coordinate system origin to a different location and change the spacing based off of that new location. So we can continue this process on as much as we like. And once I'm ready to mesh, I can leave this panel elements tool. And because I've defined a number of different mesh densities, I may want to average the mesh density for all panels. This is totally subjective to your own preferences. And we simply click the mesh panel elements button to create our shell elements. And you can see here it's created these shell elements. I've got a lot of joints, so it's a little bit hard to distinguish everything here, but I'm going to accept what I see. And now I can zoom in, and perhaps I can look at a specific location and I can see the shell elements that have been constructed. They've automatically been connected to the shells within the flanges and the webs, so I don't have to worry about doing that myself. So this takes care of that. The multi-orientation panel or multi-plane panels are automatically connected for us without any extra effort on our part. Now, if you'd like more information about meshing in S-FRAME or working with these types of geometry, please check out the other YouTube videos on our channel or look at the Altair Learning Center for more training material.